Hello, I'm Shane in Sweden, and this is the second part of our presentation on insecure deserialization threats from the OWASP top 10 list. In the last video, we looked at the background to the problem, and in this video, we're going to look at some C# code examples that we can use to illustrate exactly how this problem arises and what we can do about it. Since it's the short version of the video, we're just going to jump straight into our coding examples without any preamble. So here you can see we're sending a deserialized payload, JSON payload of an exception to our REST service. So we post our payload to the service, and here in debug mode we come into the controller in the our REST service, and we can see that we have received our string object, and using the JSON converter we can deserialize that. You can see we deserialized it to a full system exception object, which we can then persist or save. So the question is, what else can we send over the wire? Well, here we have a security blog by Peter Stuckley, and he's talking about insecure deserialization. And he actually shows here a rogue, a bad JSON payload, which is actually just sending some file info class, .NET file info class. And we're going to use this to see if we can have some fun with our system. Now, his class is based on a C# object called object, which has a file name, file info as a sub-property, which is not exactly what we want. We just want to send a file info, so we'll have to adapt this payload a little bit. And in this one, we're going to post a file info object. Now this actually is remote code execution exploit. So this is actually a gadget we're sending that's been discovered. Okay, so we need to change the postman settings. We want this to be a post. We want to post in our payload. We want to be sending a JSON payload. And we need to copy in our URL. Right, now, as you can see from the other payload, we need to comment or escape our double quotes. So we'll have to do that here for the payload, which is a bit boring, so we'll just do this very quickly. Yep. Now, the file that they had in his, Peter had in his blog was RCE test, but we want to do something more interesting, so we're going to do web config, but we don't want to crash our application, so we'll change it so that one letter, so it's not the real web config, it's a web config. It doesn't have to have any content. But if we look at that file in Windows Explorer, you can see that the read-only flag is not set. Okay, you can send the payload to it, and we come into the controller, and now you can see that the payload is a file info payload. But because we've got type name handling auto, it'll read that type from the file, and you can see it's created a file info, and you can see the read-only flag is set to true. So the execution has already happened. Now if we go to our file properties again in Windows File Explorer and look at the file properties now, you can see this read-only. So here we've actually created a remote code execution. Now this is a pretty serious attack, since you can imagine there are many files that if we lock make a read-only. For example, the log file that an SQL Server database is writing to, then the actual application will crash, and we've actually created the possibility of a denial of service attack here. Although of course there were a number of factors that had to be in place here for this attack to work. The file had to exist, we had to know the name of the file and its location. The server had to be running this type of serialization with this type of name handling, and be accepting objects that from untrusted data sources to allow this actual attack to occur. But having said that, it's quite clear also this is quite a serious attack. It's quite doable. Before we go, I'd like to show you one more code example which quite dramatically demonstrates the type of code execution that can take place when we're dealing with insecure deserialization. Now, as we saw, we can only really deserialize types that the system knows about, and some types are clearly more dangerous than others. One particular problem is the object data provider, because the object data provider actually allows arbitrary execution methods on it, and is used quite often, for example, in Windows Presentation Foundation applications. So if we can have an insecure deserialization of an object data provider JSON payload, then we can pretty much do anything we would like to. Now in this application, we have a Windows Presentation WPF browser, application. And in our tests, you can see we're going to send in an object which will then be deserialized and persisted, more or less, quite similar to what we did in the previous example. And this is the type of object we're sending in. We're sending in a mutual fund description, what the fund contains in terms of shares and companies and so on. And so if we go to our test, and we're going to deserialize, run our test here, which is deserialize non-dangerous object. If we debug this test. So we're creating our browser utilities. And we're going to store our data objects, which in this case is our payload of a mutual fund description. And so we come to the store object method, and the first thing we do, as we've seen before, we have this dangerous type name handling, and we're going to convert our mutual fund object. We check if the fund is a mutual fund, which it is, and then we persist it. So that's fine. But what happens if we generate, or if we use a dangerous payload, which in this case is our object data provider? And as we said, we can carry out an arbitrary execution on this. What happens if we send this packet in through the same deserialization? Well, let's go to our second method here, which is we can deserialize a dangerous object to show that bad things can happen. And if we debug this test, we come down to our same store data object method, and we deserialize our object, and we can see that the calculator method is executed on our machine. That's another example of what can happen when you've got insecure deserialization. Remember, this is the short version of this video, which just shows the two attacks. If you want to see how we built up the software we're using here in the different examples from start to finish and follow along by yourself, then in the links below you can find the GitHub repository where the source code is, and I suggest you look at the longer version of the video, which goes into much more explaining what we're doing step for step.